Okay, today we're going to talk about parametric equations and kind of sketching them. So the whole idea is that sometimes we can't write something just in terms of x and y. So that's when we introduce, hey, a third variable such as t, and we have this system of equations like x equals some function with t and y also equals some function of t. And we are going to combine those two to come up with some ordered pairs that will be, as you see down here, like xy is going to equal that function f of t and then g of t, and we're going to plot this collection of points. Something to note with parametric curves is that if you think over here on the left, as you look at this one, if you imagine an ant that starts at O and kind of travels here, they do have a direction on them as well. But notice here in this case, this one doesn't pass the vertical and horizontal line test, so it gives a reason for it being written a little differently than what we're used to. Okay, so let's go ahead and dive right in. This first one says to sketch the curve described by the parametric equations, x equals t cubed, which I have over here on the left in green, and then y equals 2t squared, which I have over here on the right in purple. So notice on this first one that your x-axis now is like similar to the y, and then we've got t over here on the right. This y one is more what you'd expect, the y-axis where you'd expect, and now t is almost like the x-axis. To come up with how we actually want to plot that, since we're going from -1 is less than or equal to t, which is less than or equal to 1, we know that our t values are varying from -1 to 1. So I'm just going to say -1, 0, 1. Oftentimes what we'll do here is we'll actually make some table of values and then we'll go from there. So now let's look at our x's. When t is -1, our x value is also -1. When t is 0, our x value is 0. When t is +1, our x value is 1. Okay, now let's do the same with y. When our t value is -1, our y value is 2. When t is 0, our y value is 0. When t is 1, our y value is 2 again. So what we're going to do here is we're going to plot these x's and y's together. So we're going to plot -1, 2, 0, 0, and 1, 2. So in this case, if we plot some more points in between, you may kind of understand a little bit more, but basically just connects down here and it will connect up, right? So there is a direction. Since we started with the left, we went down and then we went up. So you do want those arrows in there so to kind of understand what's going on. Okay, so now let's do one kind of from scratch, quote unquote, in the sense that I'm just giving you that x of t is equal to t minus 1 and y of t equals t squared. It's once again here, -3 is less than or equal to t is less than or equal to 2, so we're saying it's from -3 to 2. Okay, so let's go ahead and let's plug in our t values. So -3 minus 1 gives us -4. -2 minus 1 is -3. -1 minus 1 is -2. 0 minus 1 is -1. 1 minus 1 is 0. 2 minus 1 is 1. We can do the same thing for our y values as well. We're squaring it. So -3 squared is 9. -2 squared is 4. -1 squared is 1. 0 squared is 0. 1 squared is 1. 2 squared is 4. So now you're thinking about just plotting those x's and y's. -4, 9. -3, 4. It's up to you here too. Like at this stage, if you think you kind of want to go ahead and connect them and draw that arrow in so you remember the orientation, you're welcome to, or you can wait till the end. -2, 1, -1, 0, 0, 1, and then 1, 4. So at the end, you may kind of see a little bit better that this is a parabola, right? Or a part of a parabola, and then that's the orientation. Okay, look at this next one, same idea. So for our x's, we're going to do -2 minus -2t. So let's do that with the table of values. So -2 minus -2 times -3 is -2 plus 6, so we get 4. Then we're doing -2 minus -2 times -2, so -2 plus 4 is 2. Negative 2 minus negative 2 times negative 1 is negative 2 plus 2, so we get 0. Negative 2 times negative 2 times 0 is just negative 2. And then negative 2 times minus negative 2 times 1 is negative 2 minus 2, so negative 4. Same thing with the y's, but we're just adding 3 to our t values. 3 plus negative 3 is 0. 3 plus negative 2 is 1. 3 plus negative 1 is 2. 3 plus 0 is 3. 3 plus 1 is 4. Okay. And the reason why our table goes from negative 3 to 1 is because it says that, hey, our t is between negative 3. Negative 3 is less than or equal to t is less than or equal to 1. So now let's plot the points. We got 4, 0. We got 2, 1. We got 0, 2. We got negative 2, 3. And I've got negative 4, negative 4. So you'll notice this is actually making a straight line. So this is a linear equation, or part of one. It is starting from the right and going to the left, so my arrows are going to go this way. And in this case, you're probably like, that just made that linear equation more complicated, which in a lot of ways it did, right? However, we do now have an orientation or direction as well. Okay. On this next one, where it doesn't necessarily give you a table of values, I would create one. So if t is from negative pi halves to pi halves, I would probably at least go by negative pi halves, but you can even go by like pi fourths, which is a nice multiple. The only problem with pi fourths is a lot of times when you do like sine or cosine of pi fourths, right, because that's square root of 2 over 2, so it's not as easy to graph on just your axes that counts by integers. Okay, so now we're going to do cosine of negative pi halves. Cosine of negative pi halves is equivalent to negative 1. Cosine of negative pi halves is 0. Cosine of 0 is 1, and cosine of pi halves is 0. Let's do sine now. Sine of negative pi halves is negative 1. Sine of 0 is 0, and sine of pi halves is positive 1. So now think about plotting those points. We're going 0, negative 1, and then 1, 0, and then 0, 1. So here we actually have a half circle. And then since it started from the bottom and went up, it's going this way. If you weren't quite sure about that, when you add in the pi halves, you'd actually get like square root of 2 over square root of 2. Sorry, pi fourths. So you get square root of 2 over square root of 2. So then we get like that approximates to 0.7. So we'd have 0.7 and 0.7. So then it kind of gives you some other points. It'll give you those 2 points I just plotted in red if that would help you see the circle. Okay, 2 more here. Same idea though. So on this one, we want t to go from 0 to pi. So I'm going to count by pi halves. So 0, pi halves, pi. And then I'm going to have x and y. This one likely won't be a circle because notice how we're taking a negative 2 and timesing it by the cosine for our x, and we're multiplying the y by 6. So let's go ahead and start plotting some points. I'll start plugging some values and we'll plot some points. So cosine of 0 is 1 times negative 2 is negative 2. Cosine of a half is 0 times negative 2 is 0. Cosine of pi is negative 1 times negative 2 is positive 2. Okay, let's do the same for y. Sine of 0 is 0 times 6 is still going to be 0. Sine of pi halves is going to be 1 times 6 is 6. And then sine of pi is 0 times 6 is 0. So, negative 2, 0, 0, 6, and 2, 0. So, we start on the left, went to the right. In this case, you get half of an ellipse. Okay, last but not least. Okay, we're going from negative pi halves to pi halves, right? And I'm going to make this a little bigger because we probably are going to have to approximate here. So here I got negative pi halves. I've got, just for kicks, we'll do pi fourths too. The negative pi fourths, just to show you that it may help sometimes to have some more points. Okay, and then we're going to have x, we're going to have y. So sine of negative pi halves is negative 1 for our x. Sine of negative pi fourths is negative square root of 2 over 2, which we're going to approximate to be negative 0.7. Sine of 0 is 0. Pi fourths is square root of 2 over 2, which is approximately 0.7. And sine of pi halves is 1. Okay, so then on our y values, they're going to output exactly, oops, I shouldn't have done t there, even though it does output exactly what t is. This is really our y values. Okay, so we get 0, pi fourths, pi halves. And if we want to approximate those as well, pi divided by 2 is approximately, I'll say 1.6. So this would be approximately negative 1.6. And then pi fourths is half of that, so approximately negative 0.8 or approximately 0.8. Okay, so if we want to think about graphing that, we're at negative 1, negative 1.6. We're at negative 0.7 and negative 0.8. Okay, 0, 0. And then we got that 0.7, 0.8. And then we got 1, 1.6. So if I had just had the original ones, right, as you connected it, you may have just been like, oh, it's a linear equation. However, just by plotting that one more point, you would see that we kind of actually have this little curve going on here. And the direction starts on the left and goes up, so it's like that. All right, you're all set to identify some graphs on your homework. Good luck.